Hello, in this lesson I'm going to show you some new techniques. We are going to do break and trace. So let's get started. So this is another new crack me called Easy Crack Me. Let's double click and study and see what it does. Before that, I'm also going to introduce this tool to you called Detect It Easy. So it is used for detecting what language or program is used to create the crack me and whether or not there are any protectors. So we can just drag the crack me over it to open it with DiE. DiE will analyze the crack me and it will produce a report like this. And then at the bottom here, you can see the compiler used is Microsoft Visual C++, and the linker is Microsoft Linker. And then on the top left hand corner, the file type is bE32, meaning that this is a 32-bit program. If it was 64-bit program, you will see the status here written as bE64, but at the moment it's bE32. So there are no protectors. If there were protectors, you will see here protector and then the name of the protector. So let's close this now. Now we will run this and see what it does. So there is an input. Let's key in something. Click this button and it says incorrect password. Let us attach cheat engine to the crack me. This one. Click open. Now there are a few ways to solve this. You can do a reference string search for all the strings and then look for this string. That is one way, which I showed you before. Another way is to do a memory scan. So now I will do a memory scan method because I want to show you break and trace method. So now we will scan the memory for this string. Select value type string and then under search for text here, enter 2, 3, 4, 5, 6 and click first scan. We found one location in memory, so let's add it to the address table and we have our address table. Next thing we want to do is to find out what instructions access this address. So we right click it and click on this one, find out what accesses this address. This will attach cheat engine, yes. So the debugger is attached. Now we click on this button and we can see there were 3 instructions that access this address. Click one more time. Let's pull this to the right so we can see how many times each instruction access this address. Click again. At the moment it's 15, 1, 1. Let's click this. Now it's 15, 2, 2. Click again. Now it's 15, 3, 3. Click again. Now it's 15, 4, 4. So it seems that this 2 is the one we are interested in because this thing stayed at 15 when we click this. We are interested to know what happened after we click this. So when we click this thing did not change, but this 2 changed. So we can safely ignore the first one. So let's analyze this. Stop this first. Click on this and go show disassembler. And now we see we are in the system DiE alpha, not in the user module. User module is this one, Easy Crack Me. Alright, so this is not the one we are looking for. Close this. Go for the second one. Click show disassembler. Again, we are in the user module. So this is not the one we are looking for. But then when we close this, we find there's no more others. We only have 2. Both also show you the wrong module. So how to solve this? Alright, so there is one way to solve it. Now we don't know which one is it. We just try one of it first. So we click this one, and then we are in the system module. So here we can break and trace this instruction, this one. So we right click on this and put a break and trace, not breakpoint, break and trace. Then this one, no need to change the default, just click OK. Alright, so now when we click on this one, it will break and trace. Okay, so it has broken at this location, and it traced all the previous calls just before this call. So, and then after that it produced the bad message. Okay, so now let's go and analyze the break and trace. The break and trace starts from all the calls before this call, before this function. This whole thing is one region in memory. So just before this region in memory is reached, there were previous other regions in memory which came before this. So this is the trace of all the path taken to reach this. So if you want to know where this is, you can click and expand. Click expand. Click expand. So you want to expand all, just right click, expand all. And then you will see this is where we put a break and trace. And then cheat engine has detected all the previous call before this. So we know the parent of this is this one. This is the parent. So, and then the parent for this is this, and so on, and so on, and so on. So we can trace backwards, right? So, and each time we expand this, we go down to the children. So the children is nested in the parent call, right? The parent will call the first child call another child, then the child call another child, and a grandchild, and a grand-grandchild, and so on, until we reach this one. Okay, that's the meaning of break and trace. So finally we come to this line here. Now after this call finish, after this instruction finish, it will go on executing all the rest of the code here and hit the return. So when you hit the return, it goes back to the parent. So here is where you return, and it goes back to the parent here. This parent is the same as the parent here, same. Right? If you close this, you can see you are now in the parent. Right? You went back to the parent. Right? So this will tell you who the parent is. So to go to the parent, just click on this. This is a parent for this part of the memory region. You can say that this is a function by itself, and this is the parent function. Then the parent function, if you keep on tracing, will also come to a return. Somewhere there will be return. Sometimes you will find a sub call here, because this is the content of this call. It's like stepping into the call. If you don't want to step into the call, you just close this. Then we continue with the parent until we hit another return. So when we hit this return, we go back outside one more layer to this parent, this child's parent, which is here. Then we continue tracing. Notice so far we are still in the user 32, which is the one of the system DIL. We are not interested in system DIL. We want to go back to the user module. So we trace this child until it hits a return. After it returns back to the parent, go back up one layer, and this is another parent. Then until it hits the return, up one more layer, hits the return, up one more layer, hits the return, goes back up one more layer, and then here we don't want to step into the call, so we collapse this. Here is another call, we don't want to step into it, so we collapse it. Go straight to the return, go up to the parent again. So this is the parent function. Go to the return, step out into the parent again. And then here there's another call. we don't want to step into the call, we uncollapse it, trace to the return, step out into the parent, go to the return, step out to the parent, and finally we arrive at the highermost layer, which is this module. Now we are outside the system module, so we are in the user module. So from here we can start tracing, right? We can double click this and we go straight there, and we can see here, this is the Easy Crack Me, right? The user module. And then we scroll down, we can see some interesting text, and keep going down, you can see Easy Crack Me, congratulations. And then here, Easy Crack Me, incorrect password. So now we know that this is the correct location. So this is the meaning of break and trace. Okay, so then from here also we can see this is the part that we're interested in. So far, just before all this are the children. So Easy Crack Me is the user module. The user module make use of all the child functions inside it. So if you wanted to straight away go to the user module, very easy. Instead of tracing it all the way like this, which we just did, earlier on was like this, we expanded this, right? If you want to go straight to the user module in future, just scroll down to the bottom and click any one of these, and straight away it will take you to the user module. You don't have to analyze inside here one by one, but I did it just to give you the understanding of what you mean by children calls and parent calls, children function and parent function, what is the meaning of return, and so on. So now you know. So from here we can now see and analyze where we can reverse in order to show the good message. So an easy way to do this is to we know that it shows this bad message. We can confirm it. We can put a breakpoint here, set breakpoint here, and then click this and see it has hit our breakpoint. See that? If we step over, now it's going to go straight and do all the bad message here. And step over again, step over, and finally it shows you the bad message. See that? So we know we are in the right place, correct place. Click run. Okay, so now how can we solve this? We want it to show us a good message. Now an easy way to do it is to, we know that it came over here. So what we can do is we can force it to go back up here and show the good message. So in order to make it go back up here, we can change this to a jump to this address. So we convert this to a JMP and then followed by this address. Okay, that's what we want to do. But before we do that, let us add this to our code list so that we can recover it easily in future. So right click on this and then select add to the code list. Click OK. Click OK. Alright, so now if we have got it in the code list, we can easily refer to it. In case this thing suddenly closes, we can go back here. So now, how do we convert this to a jump? We can use code injection. So select this line, select tools, and then go here, auto assemble, click on template, AOB injection, click OK. This is the location of this place where you want to inject. Click OK, and the symbol you want to put here is inject. Click OK. Alright, so now instead of this, we don't want it to execute this. We want it to jump up to the top here, to this memory. So we copy this memory first, right click on this and copy the clipboard, address only. So we copy the address, we come back here, we comment out these 3 lines, 1, 2, these 2 lines, and instead here we replace it with jump, and then we paste, right click, paste the address we copy from here. Okay, so now when the program when this script is activated, it will scan these bytes, this array of bytes, and it will find that it is over here, the array of bytes. This one, 68, 10, 68, 58, 60. See, so when it finds it, it will go and insert this code. It will jump to new memory. It will insert this jump. It will insert the jump here to jump to a code cave. And in a code cave, it will execute our injected code. And this injected code will cause it to jump to this location. Okay, that's what we want to do. So now we can assign this to current cheat table by clicking File and clicking this one. Okay, now we can see in action. Let us first test this one more time. Alright, let's remove the breakpoints. View breakpoint, remove it. Let it run. Okay, now before the script is activated, we are seeing the bad message as expected. Now we are going to activate the script. So watch what happens with this line when you activate the script. Maybe we give this a name. Call this JMP. So we activate the script and you insert the jump here. This jump is referring to this jump. So it jumps to new mem. New mem is a code cave, so we can trace it. You can right click and follow. So it will jump here. Alright. So when it jumps there, this is a code cave. It will execute this injected code, which is this. Alright. So let us run. Let us see what happens when we click on this. See, congratulations. So when it came here, it jumped back. When it came here, it jumped back to the address we specify. Follow this, it jumps here and execute all these things, showing the good message. That's why you are seeing the good message here. Alright, so this is how it works. Okay, so now we can close this and save our script, our cheat table. Deactivate this first, click File, click Save, and then go to a location in a desktop. I save it on the desktop. Easy correct me, and I just give the default name should be fine. Alright, so I've saved it. So that is all for this lesson. Thank you very much for watching.